when we multiply a number with another number, means we are adding the number that many times. For example, when we multiply 2 into 3, it means that we are adding 2 for 3 times. We are adding 2 for how many times? 3 times, which means 2 plus 2 plus 2. The answer is 6. That's what it means. Likewise, if I return like 3 into 2, which means I am adding 3 for how many times? 2 times. So 3 plus 3. So both ways it is same. What happens when you multiply the number with itself? When you multiply a number with itself, we call it square. We call it square of a number. For example, you multiply 2 with 2. Meaning what? 2 added for how many times? 2 times. The answer is 4. 3 multiplied with 3, which means 3 added for 3 times. The answer is 9. Okay. Likewise, we may start from 1. 4 4s are 16. 5 5s are 25. 6 6 are 36, and so on it goes. Now, this 1 into 1 here, no, that how we can represent is 1 square, 1 to the power 2, or it can be pronounced as 1 square, and this can be written as 2 square 4. When I mention 3 to the power 2 means 3 multiplied how many times? 2 times. You see, 3 into 3. Okay. Likewise, 4 square. 16, 5 square, 25, 6 square, that is 36. Let us write up to 25. It would be helpful, and you should be aware of these squares up to 25. That would be helpful for the further calculation whenever you see a number. Okay. And let me write it up to 10. After that, there is a definition. You see, 7 square, that is 49, 8 square 64, 9 square 81, 9 9s are 81, and 10 square is 100. The numbers so obtained here, right? No, 1, 4, 9, 16, 25, 30. These are all the numbers which are on the right hand side. The numbers which are on the right hand side are called as perfect squares. The numbers are called as perfect squares. Okay. And it has one, it has to be noted that first let us write up to 20, then we'll go with that similarities. Then 11 square, that is how much? Do you know? 121. 12 square, 144. 13 square, 169. 14 square, 196. 15 square, that is 225. 16 square, that is 256. 17 square, 289. 18 square, 324. 19 square, 361. 20 square, 400. Now there are some things has to be noted here. Look at the last digit of this perfect square. It ends with 1, 4, 9, 6, 5, 6, 9, 4, 1, 0. Any other number appears? Either it will end with 0 or 1 or 4 or 6. That is all. 0, 1, 4, 6 or 9. Other than this numbers, any of the number ends with any other number, 5 I left. 5, 6, 9. Only these numbers could be the end digit of a perfect square. For instance, if you want to check whether 373 is a perfect square or not, simply by this unit digit we may decide it is not a perfect square. Why? No perfect square ends with 3. Okay. Now 182, is this a perfect square? No, it is not a perfect square. Okay. Now 181, is this a perfect square? Looks like it is a perfect square, but that need not to be a perfect square. So the statement I'm making here is, all the perfect square must be ending with 0, 1, 4, 5, 6 or 9. But the numbers which are ending with this 0, 1, 4, 5, 6, 9 are need not to be perfect squares. Have you understood the statement? Let me repeat it once again. All the perfect square has these as unit digits, but it will not apply vice versa. Only in this direction it is possible. Okay. So using that we can identify these kind of numbers, whether it is perfect square or not. Okay. Now this is all about squares. Now square root. Square root means it's a reverse process. Squaring means we have a number, we multiply the number and we will get one big number. For example, take 15 square. What is 15 square? 225. What is 25 square? What is 25 square? It is 625. What is 35 square? It is 1225. What is 45 square? It is 2025. Did I memorize all this? Does it sound like I memorized all this? No? There is a pattern followed. You see, all the numbers ends with 25. Is it or not? So whenever a number ends with 5, we may see that it ends with 25. Before 25 there is a number. Analyze that number. What type of number it is? So this 5 and 25 can be mapped. Okay, ends with 5, ends with 25. Now this 2 and 1, how these two can be related? The same way, this 6 and 2 should be related, this 3 and 12 should be related. Have you observed any pattern? What is next number of 1? So 1 2s are 2, ends with 25, that's all. Next number of 2. So 3 2s are 6, 625. Next number of 3, 4. So 4 3s are 1225. Next number of 4. Can you say what is 55 square? $3,025. Good. 30 25. 65 square. 6 7s are simply 4225. 4225. Okay. What about 105? Don't say 225. Yes. Yes. 110 after the 25. Okay. It applies for all the numbers. So whenever a square is required, you don't need to memorize a number which is ending with 5. All you need to remember is this trick alone. Now, I spoke about the square root, right? Simply, these are all called perfect squares, the numbers which are in the right hand side, big numbers. What number is squared to get this big number? This 15 is called the square root of 225. 15 is called as square root of 225. You see, square root of inside one number will write. So 81 if I write means, this 81 can be written as what? Is this a product of a number with itself? Such any numbers you find? 9, yes. So this can be factored as 9 9s are. So whenever in a square root, actually the symbol is, when here no number is there, it means there is 2. When 2 is there, we don't need to mention because that is the first root. Okay, 2 means it is square root, or sometimes it can be mentioned without any number. So without any numbers, this symbol is mentioned means, without a number, this symbol is mentioned means we can consider it is a square root. So 9. 9 is a square root of a number. So previously we have seen the unit digits, right? This unit digit relation will help us to identify what could be the unit digit of the square root. These unit digit of a perfect squares will help us to identify what would be the unit digit of the square root. So if I say square root of 289, what you will say? Which number multiplied with itself will give you 289? 17. That's all. So likewise, we have to map, we have to find a relation between these unit digits. What is that relation? Unit digit of square number, perfect square or square numbers, likewise we can call it. Okay, then unit digit of the square root, if the unit digit of the square number is 0, unit digit of a square number is 0, then unit digit of a square root would be what? Which number I said square root? It is in the left side of the equal side. Okay, so if unit digit is 0, what is the unit digit of square root? 0. Okay, now if unit digit is 1, here also we have 1, there also we have 1, here also we have 1, here also we have 1. What is the unit digit of the square root? Square numbers unit digit is 1, then square roots unit digit is, unit digit means last digit, 9, here also 9, there 1, here 9, there 1. So we have two options. If the unit digit of a square number is 1, we have unit digit of the square root is 1 or 9, either of the number. Okay, Next, 2 is not possible. 4. If the unit digit of the square is 4, which means the bigger number is 4, then 2 or 8 is our unit digit. See, 4 means here 2. 4 means 2. Here also 4 is there, but ends with 8. Here also 4 is there, ends with 8. So 2 or 8. Likewise, can you find any such relations? Likewise, can you find any other relation? If unit digit is 5, then five alone. Yes. If the unit digit is 6, then the unit digit of the square root six or 4, that is 4 or 6. If the unit digit is 9, then it is 3 or 9. So why we are writing this? Why we need to understand this? These details will help us to estimate the square root of a number. Okay. Also, to find square of a number and to find the square root of a number, we have a shortcuts too. First we will see what is the direct method to approach this, then we will go with the shortcuts. Would be helpful. Okay. Now, have you written everything? Shall I erase everything? Okay. This is about squares and square roots. We will see some examples. Have you written this unit digit everything? Okay, good. Square root of 4225. How we can find the square roots first? There are several methods. If it is a perfect square, we can easily find the square root of the number by prime factorization. The methods to evaluate, the first method is by prime factorization, and the second one is using the long division method. First, let us see about this prime factorization method. So, when I say prime factorization, do you know what is prime factorization? We have seen the same in the previous session. The number can be divided using the least prime number that can divide the given number. So, it is 5 or 3. 3 is the least prime number that can divide this. See, 1 3s are 3. Then carry over 1. That makes it is 12. 4 3s are 12. Man, this is not divisible by 3, I guess. Is it divisible by 3? You check. How will you check whether this is divisible by 3 or not? See, divisibility rules, remember? 4 plus 2, 6. 6 plus 2, 8. 8 plus 5, 13. Is not divisible by 3. So better we'll go with 5. So 5 means 4 cannot be divisible. So 4 to 42 will take. 8 5s are 40. Carry over 2. That makes 22. Then 4 5s are 20. Carry over 2. That makes 25. 5 5s are 25. So again 5 will take. So 5 means come on, how much? 1 5s are 5. Carry over 3. That makes 34. 6 5s are 30. 169. And then 169. Have you seen this number? 3 cannot be divisible. Now only I erased. That is why I told you to remember squares up to 25. Square numbers up to 25. You see 169 is a square of which number? It's a perfect square number. You should be aware of this number. These perfect squares, prime numbers, you should be aware of these numbers. See, it's 13. So how many times 13 is 169? It's 13 times. That is all. We ended with the prime number. We'll stop the process. Then this square root of 4225 will be 5 into 5 into 13 into 13. As this is square root, the number 2 is hidden here. This can be paired as 2 numbers. Like group, we'll group this as 2 numbers. From each group, one number will come out. From this group, 1 5 I'll take out. From this group, 113 I'll take out. If any other number left with pair, suppose here 7 is there, there is no pair, then we'll keep the number as it is. We should not take that number out. When it is a pair, we can take that out. Like somewhat game. See? So what is 5 times 13? How much is 5 times 13? It is? Come on, man. 5 times 13 it is? I think this much. 65. Okay. This is the method by prime factorization. Have you understood? The number we have to express that as a product of prime numbers and grouped as 2 as this is square root. We will take 1 from the group, then the remaining result can be multiplied. That is the square root of this number. It means the reverse process as I told you earlier. Okay. Likewise, yes, make it fast. shall we? Okay. You see, this is the method by prime factorization, and the next one is by long division method. Long division method that I will demonstrate you how it has been done, but you better go with the prime factorization. Even we will skip the prime factorization with the shortcut method. Okay, but you should know all the methods. Whenever one fails, you should come with the another alternatives. Okay, if prime factorization cannot be done, go with the long division. Okay, suppose if the shortcut cannot be applied, means we can go with the prime factorization. If that also failed, means we'll go with the long division method. Whichever is applicable at that moment, we have to apply that one. Okay, now the long division is simply what we are doing in division, the same manner. There is a dividend, divisor, everything, but here, is there any divisor you find here? There is no divisor. All we have is only dividend. Okay, so here it goes. The first step is to group these numbers into two numbers from the last, from the end. We should group it as two numbers using this bar, which means we are going to work group by group. First we will going to sort out this group, after that the next group. Okay, now the divisor we have to find. How the divisor should be means, it should be a perfect square that should come near to this 42. Like here 42 means what are all the perfect square numbers you list out? 1 1s are 1, 2 2s are 4, 3 3s are 9, 4 4s are 16, 5 5s are 25, 6 6 are 36, 7 7s are 49. Will it exceeds or not? This lies between 6 and 7, but 6 is the closest one, which means a number, a perfect square which is below 42 we have to look for. So that will make it as a divisor. So 6 times 6. Whatever the number you are writing here, that has to be written upwards also. That is the procedure, because we don't know the divisor. So after writing this, we have to multiply this number with this, and the result has been written downstairs. 6 6 are 36, and subtraction happens. 42 minus 36, how much? 6. Okay, then we'll bring down the other group. So I'll bring down the other group. It comes as two numbers as a batch. So it is 625. Okay, now we have to double the quotient. This number has to be doubled. So this number has doubled into 2. Whatever number is there into 2, that is 12. After doubling the number, put one dash. Here one dash, here one dash. Look at here, man. Here one dash, there one dash. Whatever the number we keep here, the same number has to be written here. For example, if I written 1, here also 1, then this 121 has to be multiplied with 1. That's how it works. If I written 2, then 122 multiplied with 2. Have you understood, or are you getting confused? Okay. Now we have to look for a number that will match or come near to this 625. As this number ends with 5, it gives me a clue that we may go with 5. So I am taking 5 here. If I am writing 5 here, the same 5 has to be written here, and this 125 has to be multiplied with 5. So 125 multiplied with 5, how much it is? 5 5s are 25, 2, 5 2s are 10, 12, and then 1, 5 5s are 5, 6. Yes, there it goes. We got 625. 0. So we ended up with the 0. Then we will take 65 as the square root of this number. This is the method of long division. Okay. Suppose if whatever the number you keep here, it will not satisfy, then what we will do? We will go with the decimals. The decimal is here, this like after the decimal, we will keep 2 zeros as a group. Suppose here only 62 is here. For example, I am saying, suppose here only 62 is here and we got 125 here. Whatever the number you replace here, it will not satisfy, right? Then we will go with the another step by using 0 here. Here 0 means there also 0. So we will put 0 0 0. We will get 62. Okay. Can you hear me?